Hello, everyone, and welcome to the February Rust Lang Los Angeles Talks. I'm your co-organizer, Cameron. Stay tuned for after the talk to hear a special announcement about the future of Rust Lang Los Angeles. Also, I'll take off these sunglasses. Tonight, we have a great talk with me again because we're scheduling out our speakers for 2021, and we're trying to fit them all into the schedule. So without further ado, we'll get started with my talk, which is about using async with GraphQL, Rust, and Apollo Federation. First, I'd like to go over our agenda. We're going to talk about GraphQL and the basics of using GraphQL. We'll talk about GraphQL schema stitching, GraphQL Federation, Rust plus GraphQL, using GraphQL with the Rust language, SQLx, which is a Rust library with PostgreSQL, actix as a Rust server. We'll see some code samples, and then we'll see some final GraphQL schemas at the end of it all. I'd like to introduce myself as well, even though you might already know who I am. I'm a father and husband. I'm from Los Angeles, California. I'm the CTO of Libretta, which is a financial tech firm in Los Angeles. I have over 15 years of experience as a software engineer, app developer, and web developer. I still code to heavy metal and neo-80s music. And I have lots of pets. Before we dive too deep into this, I'd like to take a quick detour into the usage of microservices, as they are a common consideration for new projects. Should you use microservices? Well, it depends. And to truly decide, you'll need to consider a few questions. Do you expect complexity in your apps? Do you expect to have multiple teams managing the code base? Do you have good DevOps support or Kubernetes support? Do you expect a large-scale, high-traffic website? Are you just doing it for fun? If you have doubts about any of these topics, you should also see this article from good old Martin Fowler, who talks about the microservice premium. For today, we're going to assume that you know what microservices are good for and what they're not for, and you'll enjoy using them for this project. So let's go over the basics of GraphQL itself. The typical term is that it's a query language for your API, and that's correct. It looks a lot like JSON. It's faster than REST for the most part. You'll see why. It's lighter than REST in terms of payloads. It allows for client-driven API calls. It's open source, created by Facebook. It also affords strongly typed data in your APIs. And it's kind of like SOAP for JSON, if you're old enough to know what SOAP is, and not the thing you wash your body with. It has excellent tooling. And it creates this self-documenting API, which is great for your third-party clients or vendors that want to use your APIs without having to bug you about all the features and available data. So here we have a traditional REST architecture, resulting in 2 calls to the server from the client. This is not only inefficient for both client and server, but also costs more time and more money. As we will see soon, it also results in larger payloads that include underutilized fields, kind of like buying a CD in the 90s, just to get that one song you heard on the radio. On the right, we create a GraphQL endpoint to help handle the request more directly, moving the logic of data retrieval to the server. That's more like downloading or streaming your favorite song directly. In GraphQL, there are 2 main concerns for the client and the server. The query side of things is the method for which a client can request data from the server. There are several key features here. You can supply a list of fields. You can understand the type for each field. you can traverse relations seamlessly. For instance, if we had a relation like a user and their pet, you could request a user's pet and get that pet's name and age within the same query with one call. You can use these things called fragments, which afford us the ability to reuse queries. Saves you code, basically. You have the ability to use variables to make your queries more dynamic, like looking up users by their name or their ID. And then on the other side, we have mutations, which are another portion of GraphQL. They're optional, of course. You don't have to add mutations to your APIs. They let you modify server data. And you kind of can use the same query interface to request the response after the update has been completed. They also run sequentially, which means your updates happen one by one in order. There's no weird race conditions. And you can also create special input types like an object to specify exactly what object needs to be used to create or modify data. So here we see a simple GraphQL query on the left, which lets us select some orders, pull in their ID, and then pull in some products that are in that order. It looks like pseudo JSON, but it's most definitely not your typical query language that you'd see in a SQL database. It's more of some kind of weird menagerie of stuff. And the server response is basically a hydrated version of it in the actual JSON format you'd expect. So you can see that the server takes that query and does its work to grab it from whatever location, maybe it's a database or NoSQL or who knows what, flat file. And then it creates just simple JSON and spits it back out to you exactly how you asked for it. So we see we could assume that there's other things within products like their SKU, a description, and stuff like that. And we don't need to see all that for this particular part of our product or application. So we can just skip all that and say, give me the products, their name and price, and that's it. And of course, many companies are using GraphQL in production right now. And I do find that it does solve the problem that it set out to fix. It reduces noise in our HTTP requests and optimizes payloads and server requests to minimize server responses. With that in mind, let's touch on something called GraphQL schema stitching. So what exactly is schema stitching? It's a tongue twister. It's essentially a way to create a single GraphQL endpoint that merges multiple sub-services or microservices. You can query all of your data in one place, and it allows you to create burstable microservices behind the scenes that scale up or down depending on the type of data you need to get more servers behind. Of course, historically it was deprecated by the Apollo team, a JavaScript development team that created it in the first place, but then was quickly picked up by another team called the Guild, who kind of revised it and has kept it upgraded. The downside is that it requires writing imperative schema stitching code within the gateway, which basically some people would call fragile. But the benefits of this is that you can merge external schemas into one unified schema. So say you have a Stripe GraphQL server or PayPal or Netflix, you want to kind of add that somehow into your larger GraphQL thing, you can use schema stitching really easily to do that. Alternatively, let's learn about GraphQL Federation. So Apollo is also the team that created Federation, the one that famously dropped schema stitching. It has the exact same features up front. You can kind of create a single gateway to proxy your microservices, query all that data in single requests. Instead, though, it requires your subschemas or your microservices to be annotated. So your gateway is very light. Your microservices have more information. You can also then remove your subschema code whenever you want without causing damage to the greater good, except for your apps that use it, of course. And then each service implements what it's responsible for, and anything that's not is handled by a different microservice. So the downside again in here is that you cannot federate microservices that you don't control. So in the early example of schema stitching, we don't control a Stripe GraphQL server. In this case, we cannot use Apollo Federation properly. So stitch or federate, what should you use? Well, in my opinion, if you don't need to merge together external GraphQL dependencies that you don't have control over, I just suggest using federation. It's easier. Different use cases though, so always remember. With that being said, we're going to go down the line of federation. So let's go over the basics of federation. In this diagram, we have our clients app from the web, which our clients that connect from the web, mobile, or etc. to our gateway. The client apps don't know and don't care about our microservices. They just want a GraphQL schema. Behind the scenes, though, we have our microservices, which are probably off the internet somewhere behind your network and are only accessible to the gateway app. And in this diagram, that'd be accounts, reviews, and products. Conceptually, we have things called components, which include our implementing federation services or microservices. And then in front of that, our proxy, a gateway that combines the schemas into one large consumable schema. When using federation, we have two main type helpers. We have type references, which allow a service to reference types defined externally on another microservice. And the client sees a type reference as a normal field within a type. We also have type extensions. These allow service to decorate an externally defined type with its own data. Again, the client just sees the decorated field merge into the larger type. Now that we have that sorted out, let's talk about Rust and GraphQL. While I could compare all of the features, I trimmed this down to the relevant features required to run federated services in Rust. Our two main options are Juniper and async-graphql. Juniper is great, but does not support federation or schema stitching for that matter. It has great documentation tools that I would say outweigh our other library, async-graphql. Async-graphql is another up-and-coming library. It's a little newer, and it does support GraphQL Federation alongside an Apollo gateway, which is in node.js. It also adds several other features, such as tracing, optimizing your n+1 query so you don't hit the database like 20 times for the same user ID. Lets you do basic field guards with authorization. You can do input validation. Oops. And that's it. We'll be using async GraphQL in our talk. Now let's talk about my favorite Rust database library, which is SQLx. I love it so much, and we're going to use it with PostgreSQL. So why am I using SQLx? Well, the reason why is because it was asynchronous. It was kind of the first one there for a while. Diesel didn't have it at first. It allows you to write type-safe SQL, which actively connects to your SQL server locally and verifies that your queries to your SQL database are sound and match the types. It supports all major databases you'd expect besides Oracle. All of these have native drivers, PostgreSQL and MySQL, written purely in Rust, which is great. There's a proprietary one for Microsoft, and there's SQLite, which uses the C wrapper, because they didn't want to rewrite SQLite from scratch. It also works on any runtime you want, like Tokyo or Async Standard. It supports connection pools, which is great for high-scale applications. And it supports TLS. Finally, it comes with this great command line interface to do migrations and basically manage your databases with the command line using your SQLx code a little bit. And then PostgreSQL, the elephant in the room. Why did I choose it? Well, it has out of the box better UUID support, which is great for GraphQL. It's actually better supported in SQLx for a lot of things. It just works out of the box a little better. I tried MySQL and it's kind of clunky here and there. It has overall better SQL compliance with the SQL standard, as everybody likes to talk about. It's case sensitive, which can matter to people like me. It supports massive databases. It supports PostgreSQL, but you could also just do this with geohashing for any database. And we all know that elephants are technically larger than dolphins, so this is just science right here. But it doesn't really matter if you're expecting platforms or something like AWS Aurora or GCP Cloud SQL. Choosing MySQL or PostgreSQL is up to you and your team. It just kind of works better for SQLx for me. But also see these nice libraries that work for PostgreSQL. One's Hasura, which is written in Haskell, and one's called PostgreSQL, which is written in Node.js. And both of these libraries essentially start up servers, read your schemas directly from the database, and create GraphQL endpoints with mutations and queries automatically. Like PostgreSQL is amazing. Now, of course, there are many options out there for servers in Rust, but I find that actix fits my needs the best. It's just a slim web framework, which is just like Tide or Warp, but I just like actix a little bit better. It's very fast. You'll see the benchmarks online. It supports async with Tokyo. Most of them do, actually. There's a lot of community usage of actix, so there's good tutorials everywhere. It's got okay documentation. Doesn't really matter if you can find good tutorials. A lot of companies are using it on production, including myself. So it's a tried and true library. And it has mature plugins. And finally, it plays very nicely with SQLx and async-graphql. Again, the other libraries like Warp and Tide also play pretty well with async-graphql, but I find that SQLx plays especially well with Warp and actix. So those are my top two. Anyways, let's get federated. I was looking a lot for federal stuff. This is from Starship Troopers, but it pulled up a lot of stuff of Jason, the tennis player Federer, so I was kind of annoyed. I'm like, I don't want Federer. I want federations. Anyways, side note. In our system, we have an Apollo gateway server that federates two microservices. Note, again, that this is running in Node.js. There's no current library that does Apollo gateways in Rust. Our coder service handles the information about distinct users in our app and provides queries to find all coders or single coders by IDs. It also has mutations that handle the remaining CRUD of a coder: create, update, and destroy. Our skills service handles the data about skills a coder might have and also provides queries and mutations similar to coders. It also decorates a coder object that's from an external service, the one we mentioned above, with a list of skills that the coder may have. Before we look at the microservices, here is the simple gateway I was talking about. It's written in TypeScript for Node.js and is just one file. Notably, we have a service list here in the middle that informs Apollo Gateway about the location of our sub-schema services. This is great because our microservices don't have to be on the internet. They can be kind of behind a firewall. Here in our Rust code, we have a cargo workspace with the two microservices listed, each implementing their own chunk of our larger GraphQL schema. Also, you'll see each microservice stores its own migration data. I will walk through some of this code, and there's also a GitHub link available at the end for reference and also in the description of the YouTube video. In our coder service, we just provide the basic struct for the coder type, and async-graphql handles the rest. We have a UUID that corresponds both to GraphQL UUIDs and the database column, and we have a created@datetime field for some extra meta. Our implementation of the coder struct connects the code to the database with some basic CRUD operations, as you'll see here. And our setup with async GraphQL is also a breeze, as we just need to wire up our CRUD operations with our GraphQL query and mutation definitions, which creates a service schema. So here we create the query, and we implement the query right below. Then we create some mutations, and we implement those right below. And then we just tell our schema for async GraphQL, here's our query, here's our mutation. In our skill service, we also provide the basic struct for the skill type, and async GraphQL handles the rest. Here we create an external key to a coder via ID. Oops. My arrow disappeared, which is stored in the database. Yes, this creates a many-to-one where many skills may belong to one coder. Of course, to simplify today, I opted for this over a many-to-many setup. So instead of having distinct skills, they're kind of tied to a coder. We also have a UUID that corresponds to both the GraphQL UIDs and the created at, just like we did in coders. The model CRUD and server setup is essentially the same for the skill service, so I've skipped it. A more interesting concept here is in our skill service. We can reference an external type called coder and just provide a skeleton of an ID to link to it. Then we can implement coder with a new property called skills here that decorates each coder with a resolver to an array of skills, here seen as a vector of skills. So you can see the actual expanded code. I can call read by coder, and it calls a skill helper function to request stuff from the Postgre database. Here again is the original coder struct. And then when this microservice for coder starts, we see that the basic query for the coder shows the same fields. This is a screenshot from a GraphQL GUI. And then here in the skill service, if we inspect its graph, we see the decorated coder with the additional field skills, a reference to an array of skills. Finally, when we turn on our gateway with the Apollo Federation, the two schemas are merged together into one to create the final schema for clients to use. So that far right box is what the clients will actually see on the internet. Makes it easy for us, right? Let's go over a little bit more about the final queries. So here we have on the left the two microservices query definitions, coders above, which has a list of coders or coder by ID, and then you'll see those two underscore fields are kind of the secret federation query fields that are not exposed to the final gateway. Same with skills, you can find skills or skill by ID. And then when they're combined together in the gateway, all you see is the coders, skills, and skills by ID. And the rest of those fields are kind of suppressed. Likewise, here on the left, we have our two microservices mutation definitions. So our create, delete, and update coder mutations, and our create, delete, and update skill mutations. These are our basic CRUD operations besides read, which are inside the other section. In the gateway, again, we see that they're merged together into one single mutation without showing off those other federation metadata. So while I'd love to take a deeper dive into GraphQL and the Rust code, I see this as an introduction to the use and need for federated GraphQL systems. I hope you found it fulfilling and informative. So we've taken two distinct microservice GraphQL endpoints and merged them into one, making for an easy, scalable architecture using Rust, GraphQL, and Apollo. Here's the GitHub URL for this project, which I've also pasted into the live stream. Let's copy it right now. 1 second. Or not. I have two different computers. I'll paste it in a second. 1 second. Also, one last thing. I'm grateful for everyone joining today and on the previous talks. We've had a bunch of great speakers. We have a bunch of great speakers lined up for 2021 that I think you'll enjoy. Please sign up to speak using our link. And as an important announcement, we are going to be merging with the other Rust Lang Los Angeles meetup, which already has a large group of over 400 members. So we'll be kind of merging into there as one. And I'm going to become a co-organizer for that group alongside Drew, if you guys know Drew. And we encourage you to sign up to speak here, as well as join our Slack, which has just people from Los Angeles and nearby talking about Rust and other things. The reason why I want you to encourage you to sign up to speak now is because we already have a large list of other people from the other meetup, so we're going to have to merge them together. So I wanted to get people's names in as soon as possible and get our schedule for 2021 figured out. So there's more news to come. I'll keep you guys posted, and by March we should be fully merged into one meetup. And we'll continue to do our monthly meetups on the second Wednesday of every month, interspersed with other things like pair programming or different things like that. Yeah, we love Drew. I just saw your chat message. So I know it's a short meetup today because I don't have much to talk about besides that presentation. We had a scheduling snafu with our other speaker, so I kind of had to add myself as the last minute speaker. So I wrote this presentation like on Sunday night. But anyways, thank you for your time. Have a good week. And keep an eye on our Wrestling LA. Join our Slack, and we'll keep you posted on Meetup or on Slack. Thank you, everyone. Have a good night.